All right, this question says, circle the strong electrolytes below. If you haven't already watched the previous question, I would start with that. So strong electrolytes are going to be ionic compounds which dissolve in water, not in metal. So they're going to be ionic compounds which dissolve in water. And ionic compounds are going to be compounds which contain a metal and a nonmetal, or a metal and a polyatomic ion, or occasionally NH4 plus, the positively charged polyatomic ion that's taught in general chemistry. But if you look here, C6H12O6, this is not an electrolyte. This is glucose. It's definitely soluble in water, but it's not an electrolyte. Why? It does not contain a metal. So this is a covalent compound. Now, when we look at potassium nitrate is a covalent, an ionic compound. How do we know it contains potassium? This is an ionic compound. It contains barium. This is an ionic compound. It contains calcium. These are all metals. So now we need to see if these things are soluble in water. To do that, we need to use the solubility rules. And the solubility rules are slide number 10 of the chapter 4 notes. All right. And most of them are going to be anions, all right, with a few cations. So the 1A metals, including potassium, which is in the first example, KNO3, are always soluble. All right, so soluble on the top, insoluble on the bottom. So potassium nitrate is going to be soluble, and therefore it's going to be a strong electrolyte. So if we go back to our sheet here, we have potassium compounds, which are always soluble, nitrate compounds, which are always soluble. So this is soluble. So this one is a strong electrolyte. Let's look at barium sulfate. Now, as I said before on the solubility rules, the only cations on there are the 1A metals and NH4 plus. So potassium, lithium, potassium, sodium, so on and so forth, okay, are going to be on there. Barium is not going to be on there. So what we're going to need to look for is the anion sulfate. So if we go to the solubility rule and we find sulfates are on the top, so they're generally soluble. All right, soluble up here, insoluble down here. But if we look at this more carefully, barium is an exception, meaning that barium sulfate is not soluble. Barium sulfate is actually things that they use for a contrast in CAT scans and things like that. So basically is not a soluble compound. So this compound is not soluble in water, therefore it can't be a strong electrolyte. Let's look at calcium chloride. Again, we're not going to find calcium on the table, so we have to look at the anion chloride, the negatively charged ion. So if I go back over here and I look at chlorides are on the top, so they're generally soluble. If I look over here, calcium is no exception. So calcium chloride is a soluble ionic compound, and therefore it is a strong electrolyte. So covalent compounds are going to be not strong electrolytes because they don't break up into their ions when they dissolve in water. Again, see the previous question where we talked about how they break up into ions when they dissolve in water. And insoluble ionic compounds are also not going to be strong electrolytes because they simply just don't dissolve in water, so therefore they can't be strong electrolytes. So compounds that dissolve in water to form ions, which is soluble ionic compounds, are your strong electrolytes.